Aromatic nitriles, that is ARCN, are not prepared by reaction A. ARX plus KCN, B. ARN2 plus CuCN, C. ARCONH2 plus P2O5, D. ARCONH2 plus SOCl2. Halogen have minus I and plus M effect, by which its electron delocalized in benzene ring by resonance, and due to minus I effect it is bonded with benzene ring and cannot be substituted by Cn minus, and shows the inertness against KCN, while other options gives aromatic nitrile. So Ag AR N2 plus CuCN will give ArCN plus N2 plus Cu plus, and ArCONH2 in presence of P2O5 will give ArCN, and ArCONH2 plus SOCl2 will give ArCN plus SO2 plus HCl. So option A is the correct answer. CH2Br in presence of aqueous KOH gives A, which of further reaction give B, and with ammonia and heating gives C, and with bromine and alkali gives D. So we have to find out what is D. So when ethyl bromide in aqueous KOH alkaline medium on heating gives ethyl alcohol, which on treating with KMnO4 and H plus ion will give primary amine CH3NH2, which on reaction with bromine in presence of alkali gives CH3CONH2, which is C, and on reaction with ammonia CH2Br on reaction with aqueous KOH gives A, which on further reaction with KMnO4 in presence of H plus ions gives B, on reaction with ammonia and heating gives C, and on presence of reaction with bromine and alkali gives D. So we have to find out what is D in this reaction. So in the reaction, when ethyl halide, that is CH2Br, reacts with aqueous KOH gives A, which is ethyl alcohol, which on reaction with KMnO4 in presence of H plus ion and heating gives acid. This is oxidation. Acid on reaction with ammonia gives C, which is CH3CONH2, which on reaction with bromine and alkali gives D, which is primary amine, that is methylamine. So option C is the correct answer. Anilinium hydrogen sulfate on heating with sulfuric acid at 453 to 473 Kelvin produces A. benzene sulfonic acid, B. anthralinic acid, C. aniline, D. meta-aminobenzene sulfonic acid, E. sulfanilic acid. So when anilinium hydrogen sulfate, so structure will be benzene ring attached to NH3 plus HSO4 minus, on heating will give zwitterion, NH3 plus and SO3 minus, which on rearrangement gives sulfanilic acid. Structure of sulfanilic acid is benzene ring attached to NH2 aniline, which is attached to SO3H at para position. So option E is the correct answer. Nitro group is nitrobenzene is A. ortho director, B. meta director, C. para director, D. ortho and para director. So presence of nitro group decreases electron density at ortho and para position. Hence incoming electrophile goes to meta position. Therefore it is meta directing. As when nitro group is attached to benzene ring, it shows 4 resonating structures. So option B is the correct answer. Ethylamine undergoes oxidation in presence of KMnO4 to form A, an acid, B, an alcohol, C, an aldehyde, D, a nitrogen oxide. So when ethylamine CH3 CH2 NH2 on oxidation in presence of KMnO4 will give an aldimine. Structure of aldimine is CH3 CH double bond NH, which on hydrolysis will give aldehyde. So option C is the correct answer. Reaction of primary amine with aldehyde yields A amide, B aldimine, C nitrile, D nitro compound. So primary amine reacts with aldehyde, gives an aldimine. The structure is RCH2N double bond CH R plus water. So option B is the correct answer. When acetamide is treated with HNO2 gas, evolved is A hydrogen, B oxygen, C nitrogen, D methane. So when acetamide, the structure of acetamide is CH3COO NH2, reacts with HNO2, that is nitrous acid, acetic acid is formed along with nitrogen gas plus water. So option C is the correct answer. The reaction of alkyl nitrile yields an alcohol, a base, amine or acid. So reaction of alkyl nitrile, that is RON double bond O, that is alkyl nitrile with hydrogen in presence of SnNHCl gives alcohol plus ammonia plus water. So option A is the correct answer. Chloroform when treated with aniline and alcoholic QH gives A phenyl cyanide, B phenyl isocyanide, C chlorobenzene, D phenol. So when chloroform, that is CHCl3, on reaction with aniline plus KOH will give phenyl isocyanide. The structure of phenyl isocyanide is benzene ring attached to N triple bond C plus KCl plus water. So option B is the correct answer. The product of mustard oil reaction is A alkyl isothiocyanate, B dithiocarbonamide, C dithioethyl acetate, D thioether. So mustard oil reaction is when ethyl amine CH3 CH2 NH2, which is primary amine, on reaction with CS2 carbon disulfide in presence of HgCl2 mercuric chloride gives ethyl thiocyanate. The structure of ethyl thiocyanate is CH3 CH2 N double bond C double bond S plus H2S. So this is ethyl thiocyanate. Option A. Maximum number of NO2 group that can be introduced by nitration in benzene is usually. So the reaction of benzene undergoing nitration in presence of nitrating mixture will give 135 trinitrobenzene. So 3 nitrogen groups can be induced. Option C is the correct answer. The reaction of R2C double bond N NH2 with sodium ethanoate gives R2CH2 plus N2 is called. So in this reaction, it is Wolff-Kishner reduction. The reaction takes place in presence of ether. The reaction goes as R2C double bond N NH2 in presence of C2H5ONa will give R2CH2 plus N2. The reaction is C, carbon is double bond to alkyl and ketone is formed. In presence of H2NNH2, here dehydration takes place and the product is carbon is attached to 2-alkyl group, double bond N NH2. In presence of C2H5ONA, it gives an alkane plus nitrogen gas is released. So option D is the correct answer. Primary nitro compound when react with HNO2 form crystalline solid, which on treatment with NOH give A red solution, B blue solution, C white PPT, D yellow coloration. So when primary nitro compound, that is RCH2NO2 with HNO2 will give nitrolic acid. The structure is RCNO2 double bond NOH, which on reaction with NaOH will give RCNO2 double bond NONA. So here the side chain hydroxyl group is affected and the color is blood red in color. So a red solution is formed, option A. Secondary nitro compound when react with HNO2 form crystalline solid, which one on treatment with NaOH give. The secondary nitro compound is R2CHNO2 in presence of nitrous acid will give R2CNO2 and double bond O, which on reaction with alkali NaOH will give blue color. So option B is the correct answer. The compound which on reaction with aqueous nitrous acid or HNO2 at low temperature produces an oily nitrosoamine is A diethylamine, B ethylamine, C aniline, D methylamine. So reaction of diethylamine is a secondary amine C2H5 twice nitrogen NH plus HNO2, which can be written as HONO, which is aqueous, give diethyl nitroamine. The structure is C2H5 twice nitrogen and double bond O plus water. So this is diethyl nitrosoamine, option A. Which will not undergo for diazotization. Diazotization, that is action of nitrous acid which is prepared by NaNO2 plus HCl gives HNO2, is given by aromatic primary amines having NH2 group directly attached to nucleus in an inorganic acid leading to formation of diazonium salt. In option B, NH2 is not linked directly to the benzene nucleus, hence it will not undergo diazotization. It is attached to methyl group which is attached to benzene nucleus. So option B is the correct answer. Identify the product in the following order. 3,4,5 tribromoaniline on diazotization and further reaction with H3PO2 gives. So the reaction of 3,4,5 trinitroaniline, the structure is which on diazotization will give diazosalt of 3,4,5 benzene, which on reaction with H3PO2 will give tribromobenzene. So benzene group is not affected. So nomenclature changes to 1,2,3 tribromobenzene, option B. Ethylamine on heating with CH2 in presence of HgCl2 forms. So when ethylamine, which is primary amine, reacts with carbon disulfide in presence of HgCl2 gives C2H5NCS plus HCl plus mercuric sulfide. So option A is the correct answer. The end product of the reaction ethylamine with HNO2 will give A, with PCl5 gives B, and KCN gives C is. So here we have to find the end product. When the ethylamine reacts with HNO2, the product A is ethyl alcohol plus nitrogen plus water. So when alcohol is treated with PCl5, it gives ethyl chloride plus POCl3 plus HCl. So B compound is ethyl chloride, which on reaction with KCN will give propane nitrile C2H5CN plus KCl. So option C, triethylamine, is the correct answer. The reaction between a primary amine, chloroform, and a few drops of alcoholic COH is known as. So when primary amine reacts with CHCl3 chloroform plus KOH, which is alcoholic, isocyanide is formed. The structure of isocyanide plus KCl plus water. So this reaction is known as carbyl amine test. Option B. A nitrogen containing organic compound on heating with chloroform and alcoholic KOH evolved very unpleasant smelling vapor. The compound would be. So when benzyl amine C6H5NH2, which is primary amine, reacts with chloroform plus KOH, which is alcoholic, gives benzyl nitrile isocyanide. So this is benzene isocyanide, which gives foul smell, plus KCl plus water is formed. This is a carbylamine test reaction. So aniline is the compound, which is the correct answer. Reduction of methyl isocyanate gives A ethylamine, B methylamine, C dimethylamine, D trimethylamine. So when methyl isocyanide CH3NC undergoes reduction in presence of lithium aluminium hydride in ether, which is the catalyst used, and solvent, will give dimethylamine. So option C is the correct answer. Identify the final product in this following reaction. So when this compound is heated in presence of NaHBF4, there will be closure of the ring, formation of when this compound react with NaBH4, there is a reduction reaction which will abolish the double bond NH. This compound is formed. So option D is the correct answer. Among the following, the weakest base is. Although nitro has powerful minus I effect, yet a carbonyl group is much stronger resonance effect. So carbonyl has much stronger resonance effect than nitro. Therefore, CH3NHCHO is a weakest base. The resonating structure will be CH3 N double bond, a lone pair of electron, H carbon. Carbonyl has a resonating structure with CH3 double bond NH plus C single bond O minus NH. Here this lone pair of electrons forms the double bond. An electron from here bond shifts to oxygen. So option D is the correct answer. When acetamide is hydrolyzed by boiling with acid, the product obtained is the amino group is replaced by hydroxyl group with evolution of nitrogen when treated with nitrous acid, that is acetic acid is formed. So the reaction will be when CH3CONH2 acetamide with nitrous acid will give acetic acid plus nitrogen plus water. So option A is the correct answer. A nitrogen containing organic compound gave an oily liquid on heating with bromine and potassium hydroxide solution. On shaking the product with acetic anhydride, an antipyretic drug was obtained. The reaction indicates that the starting compound is A. Aniline, B. Benzenamide, C. Acetamide, D. Nitrobenzene. So when benzenamide with bromine and KOH will give C6H5CONHBr, which on reaction with KOH will give C6H5NCO, which on further reaction with KOH will give C6H5NH2, aniline plus K2CO3 is formed. So when aniline, that is C6H5NH2, reacts with CH3CO twice of oxygen, will give acetanilide, which is an antipyretic drug. So acetanilide, the structure is CH3CONH C6H5 plus acetic acid is formed. So acetanilide is the antipyretic and the starting compound is benzamide, option B. Benzamide on reaction with POCl3 gives. So structure of benzamide is this, which on reaction with POCl3 and heat will give benzonitrile. The structure of benzonitrile is benzene attached to CN nitrile group plus water is formed. So option D is the correct answer. Ethylamine can be obtained by A. Action of ammonia on ethyl iodide, B. Action of ammonia on ethyl alcohol, B. Both A and B, D. None of the above. So we have to obtain ethylamine. The reaction of ethyl iodide, that is C2H5I with ammonia, will give Hi plus ethylamine C2H5NH2. This is the first reaction, and the other one is ethyl alcohol, that is C2H5OH plus ammonia will give water plus ethylamine C2H5NH2. Ethylamine is a primary amine. So both A and B gives ethylamine. So option C is the correct answer. In the reaction, your X is, so one reaction is reduction reaction and the other one is hydrolysis. Hydrolysis gives acid and reduction gives primary amine. So this reaction is possible with nitrile, that is R C triple bond N. On reduction, it gives primary amine R CH2 NH2. And on reduction and on hydrolysis, in presence of water, it will give acid plus ammonia. So option B is the correct answer, nitrile. Which of the following is converted into an alcohol on treatment with HNO2? A. Ethylamine, B. Aniline, C. Dimethylamine, D. Triethylamine. So primary amine gives alcohol when react with nitrous acid. But methylamine is an exception. Methylamine on reaction with nitrous acid will give CH3O single bond N and double bond O plus nitrogen plus water, or methylamine with nitrous acid can give acetone, no it's not, CH3 with oxygen and CH3 plus nitrogen plus water, and ethylamine with nitrous acid will give alcohol. So option A is the correct answer.